actually more than 3 states of matter. Contrary to what your science teacher probably told you, there's a 4th state of matter known as plasma. It's actually what stars are mostly comprised of, such as the sun. Plasma is very effective for cutting metal signs because of the high energy in it. It can blast straight through them like butter. This is cool because you can create custom metal signs for your friends or family. There's a specific process that we must undergo to plasma cut a sign. As a CNC machinist and a CNC plasma owner, I feel great pride in discussing this topic with you today. We'll be going over the process of actually cutting the plasma sign, and I've broken it down into 3 steps, which would be designing the sign, generating the code for the sign, and then actually going ahead and cutting the sign. The first thing we must do is decide what do we want the sign to actually be. So then what we're going to do is search for images, and there are certain things we'd like to look out for in images. While this image does look better, it has a lot of background motion going on and lots of different colors. If we can find a more simple image like this with high color contrast and not much going on in the background, it's a lot easier for me to go ahead and trace the image. From there, we're going to save this image, and then we're going to upload it to our design software, which would be something like Inkscape, which will give us the online tools to be able to trace it. We can attempt to use the trace bitmap feature, which will automatically try to trace the image, but I do urge caution in this because often the computer gets it very wrong, or we can trace it by hand. Once we do trace it by hand, there will be these little nodes, and that's essentially what we clicked around to actually trace the image. Things like this, whenever you try to use the automatic trace feature, often come up like a little tumor on it, and I decided I didn't want this tumor, so I'll go in and manually edit the nodes, and it'll smooth it out like this. So that way, whenever we're cutting the sign, it's not going to have a tumor like that right there on the wheel where we don't want it. From here, we want to save this as an SVG file, not a PNG file. If you were to zoom way in on a PNG file, it's really grainy, and that's not good to run for the machine. Instead, we want to save it as an SVG file because it's really smooth, and the machine would rather read that kind of code. So now we get to segue into generating the actual code. From here, what we're going to do is we're going to open our computer-aided manufacturing software. Langmuir Systems, who produced my plasma table, they recommend you use Fusion 360 because it's very easy for beginners to learn. What we're going to want to do is open the .svg file that we created earlier, and then we're going to go to the Setup tab. For the Setup tab, the important thing we want to look at is setting our origin at the bottom left corner. So that way the machine knows where we're actually going to have the sign, so it knows where to start from and then actually go and cut. Then we're going to click within the sketch, and that way right there it says where the sketch would be, and then it knows that we want to cut out this line. Like, we don't want to cut out this box or anything like that. We want the actual sketch we made. From there, we're going to go to our 2D cutting tab, which we're going to select our tool, which I've already made the tool and put it in the online program, so all I have to do is select it so it knows what to write the code for. And then we're going to select our feed rate, which Hypertherm, the leading manufacturer in plasma cutters, they recommend referring to your actual plasma cutter manual for how fast you're going to cut it. This depends on how thick the steel is, because if the steel is really thick, you're going to want to cut it slower, or if it's really thin, you're going to want to cut it faster. From here, we're going to move on to the geometry tab, this is important for, you want to select all the little holes in the image, and then if it's an inside hole, like you're cutting out a hole, you want to make sure this arrow right here is on the inside of the hole. And then if you're cutting the outline of the sign, you want to make sure the arrow's on the outside of the hole, so that way it goes around the image instead of cutting on the inside of it, which would mess up your dimensions. Razor Weld recommends having a cut height of 0.063 inches. Razor Weld is the manufacturer of my actual plasma cutter, and that's how high the torch will be cutting above the metal. If you go higher or lower, that impacts the cut quality. But once again, Razor Weld recommends that as our cut height. Langmuir Systems, the manufacturer of my table, recommends having a pierce delay of 0.5 seconds. That's how long it takes for the plasma cutter to shoot through the metal. From here, we're going to save it as a .nc file, and that's going to be the code generated that we're going to upload to our machine. Now we finally get to move on to the exciting part, which is going to be cutting. First thing we're going to want to do is turn on our air compressor. This is very important because plasma requires pressured air to blast through the material. Then we're going to turn on our actual plasma cutter, and then we're going to turn on the plasma table. From here, we're going to plug in our computer to the running software, and then we're going to open our file. Then we're going to zero the X and Y axis. What this is important for is this moves the table to where we want to cut it on the table. So it could cut anywhere around here on the table, but we want to move it specifically to this point. So I can actually go in and just move the table using these little pads right here. And then once I have it to the desired location, I'll hit zero all axes. And then from there, you get to hit, you just hit cut, and then it'll start cutting out the design you made. So if you were to look at this in real life, this would actually burn your retina. So I recommend wearing a welding helmet, or just don't stare directly at it. You're fine looking at it on the video. You're not going to be blind from that. That's actually what the process looks like. So to go over what we went over today, we went over how to design your plasma sign, how to generate the code for the sign, and then how to actually go and cut the sign. I understand this is a complex process and that you may not have understood everything, but if you get nothing else, I hope that you guys find something you're truly passionate about and learn as much as you can. I look forward to seeing everyone else's speech today. And thank you, and have a wonderful day.